Okay, so yeah, welcome everybody to the virtual town hall for OpenImageIO. This presentation is we're going to be co-presenting myself and Larry Gritz, who's the longtime maintainer and one of the main authors of the project. My name is Danny Greenstein. I also work at Sony Imageworks alongside Larry, and I've been, I think, one of his loyal customers at Imageworks, and recently have gotten more involved as the chair of the TSC, the Technical Steering Committee for the project. So we're gonna talk a little bit, small introduction for the project for those who are not familiar with it, and then I'll hand it off to Larry a little bit to talk about the map of the project and what we're looking to achieve going forward. So I'll get started. So I see a lot of the people here are people that are probably familiar with the project, so some of this stuff is going to be familiar to you. But I'm doing a brief introduction for those of us who are here perhaps for the first time. So OpenImageIO is a library for reading images, reading, writing, manipulating images. It is heavily used in VFX and animation. It has a command line tool called OpenImageIO tool, which is known as the Swiss Army knife of the industry for image manipulation. Many of us use it every day. It has a rich API in C++. It has Python bindings. We've talked about OpenImageIO tool, but there's also a utility called MakeTX that we use to make bitmap textures. So at Sony, for example, all of our textures are made with MakeTX, and pretty much a standard in the industry. It's used in a lot of DCCs and a lot of renderers. It's integrated in OSL, Material X. It's the workhorse of the industry when it comes to making and reading images. It's included in several Linux distributions as the base, as one of the base packages. It has a long history. It started in 2008 as an independent open source project that Larry started. Recently celebrated its 15th anniversary. And a very recent development is it was accepted to the Academy Software Foundation. And we're kind of in transition right now. The project is moving from being an independent open source project that is curated a lot by Larry to go into the kind of the ecosystem of the Academy Software Foundation / Linux Foundation. So this is one of the kind of the main things that we wanted to highlight today is where we are in this transition. We are currently under the management system of the Linux Foundation, and that comes with kind of a backend of several subsystems that they give us. So they give us a new mailing list that you can see here. Soon we'll have a new Git repo that will be managed by the Academy Software Foundation. There is a new contributor licensing agreement, easy CLA, and that makes it really easy for contributors to sign off and approve their contributions. It's a lot easier than what we had before. Before you had to submit manual PDFs for approval, and now there is an automated system from that. That is a benefit that we get from the new the new framework that we're under. If you work for a large company, please have your company sign the new CLA, and that will make all your contributions later on easy to merge into the project. As part of this transition, we're also changing the licensing scheme. So we're moving to Apache 2, which is kind of the preferred license for a new project. So we're in the middle, hopefully closer to the end of a big relicensing effort of all the existing code. As far as lines of code, we've reached out to many contributors, and we're about almost 100%, 99.5% relicensed on lines of code. But there are a lot of small files that have just tiny bits in them that are still not relicensed. So as far as file count, we're around 79, 80%. But the majority of the code has been relicensed. And if you have previously contributed, there is a pull request there that you can sign off to relicense your previous contributions. So please do so, as we're trying to hit that 100% goal as best as we can. And I'll hand it off to Larry to talk a little bit about the internals of the project and some upcoming efforts.
Sure, thanks. So not knowing who will eventually see this, I wanted to give a bit of an overview of kind of the overall layout of OpenImageIO, and it's a little bit like the the allegory of the blind man and the elephant. Like, some people deal with parts of it and don't know the rest of the pieces. So maybe there's something here that everybody can find something they didn't know about before. So at the heart of it and how the project started are the two classes that we call image input and image output. And the idea there is to present a single, as simple as possible API for reading and writing images from disk files that is not format specific. So like, any individual formats like, TIFF or JPEG or VXR, they each have their own library that has completely different conventions for file layouts and APIs for their libraries and everything. And managing all that in an application that wants to deal with more than one image file format, it gets cumbersome pretty quickly. So that was the core idea behind what this library was meant to accomplish. Next slide, please. Oh, no, did you miss one? No, that's fine. Okay, yeah, stay there. So, right, so image input and image output, it's really a file level abstraction. So it has, those sort of file familiar concepts. It's a thing that you open and close, you read metadata from it, you own the memory, and you read a scan line at a time or a tile at a time and put it into the memory that, ask it to put it into the memory that you own. There are some helpers like read image. You don't really have to do a scan line or a title at a time, but that's just a really simple wrapper around asking for all the scan lines or tiles. One thing that it does for you is it will hide the details of the data types. So like just in this little example I have here, I allocate a vector of floats and I just say like, okay, like give me the whole thing, and, and fill in my float array. And you really don't have to know like how it's stored on disk. So that's one of the key ideas there. Next slide, please. So, so then the individual file formats are all implemented as separate modules, which are pretty much independent of each other than, implementing subclasses of those types. And so we have I think we have, I don't know, 15 or 20 different file formats that we support, including all the major ones that are used in the industry and many that are not. And that is really easily extensible. And it's extensible at runtime too, because we support dynamically loaded plugins that implement individual formats. Next, please. So on top of this, the next level of abstraction that oh, wait, you missed one. Yeah, hold it here. Yeah, on top of this, the next level of abstraction that we implement is the image buff. And on top of that, a large collection of functions called image buff algo. Next slide, please. So the abstraction level here is that we're no longer dealing with files or scan lines or any of that kind of thing. There's just an image object, more or less, that you kind of manipulate as a whole. It owns the memory, the application doesn't need to, and it just looks like a float array. You can access individual pixels if you have to, but that's not really the main kind of thing that you're doing with it. Although, as an advanced implementer of things, there is an efficient way to iterate over all the pixels and handle the cross product of all the different data types that they could be, but most ordinary users don't have to do that. Next slide, please. Yeah, because there's this image buff algo that has like, a really wide variety of things that you would want to do to images, mostly whole image operations. These are all automatically multi-threaded, and it's everything from generating different kinds of patterns to image transformations and copy things, cutting and pasting and selecting subsets of channels or reordering them, resizing, compositing operations, convolutions, blurring. You can use it to compare images and find what the difference is, compute statistics on the channels, things like that. And a bunch of interesting, mostly VFX specific image restoration things, like, we all know that we can get images out of renders that, have, funny nan pixels or holes or things, and there's stuff in there that can repair those, which is really handy. And OpenImageIO powered color management. So you can do things like color space transformations, and pretty much all of the major OpenImageIO style operations, applying looks and display transforms and things like that. There's wrappers around all of those, so you can do it from the OpenImageIO side and not really needing to also have to crack open the OpenImageIO APIs as well. Next slide, please. So just as an example of what this kind of thing looks like it's a pretty high level of abstraction. So you can have image buffs that reference files on disk, or local buffers that you fill, and pretty simple whole image operations. In this case, we're just doing a compositing, classic over, and then writing it back to disk. And all of the details of file formats and things is just implied in when you're reading what kind of file it finds, and when you're writing, it's just all implied by the extension that you give, and it handles all of the translation stuff for you. Next slide, please. Great, and there, the core library is C++ implementation and APIs, but we also have on all of those major classes Python bindings as well. So a lot of people, do a bunch of Python scripting around this on top of it as well. Next slide, please. So just as an example of the Python bindings, just taking the same example that we had in C++ and translating it into Python, it's about as one-to-one straightforward as you can get. There are other corners of it where things have to differ in order to be more Pythonic, or to get around things that are in the original APIs are kind of very C++ centric, but over 90% of it, it's just the straightforward mapping that you would imagine. So if you're fluent in the C++ API, you can do the Python pretty easily, and vice versa. Like the most of the knowledge carries over. Next slide, please. Great. So now on top of those are some command line tools, and there are several minor ones, but the two that people deal with most frequently are OpenImageIO tool and MakeText. So MakeText is pretty special purpose. It doesn't do anything that OpenImageIO tool can't do, but because it's a little bit more narrowly focused for generating textures that renderers can read, there's a little bit less hoop jumping to go through when that's the specific thing that you need to do. But I'm going to talk about OpenImageIO tool. It's the more general one. Next slide. So for a lot of people, their main use of OpenImageIO at all is through this command line utility. So it's worth talking a little bit about the kind of things it can do, because it's super flexible. So it's command line oriented. The command is the arguments, and it's basically, a state machine with a stack. So an argument on it processes right to left in order, and an argument that appears to be an image name, implicitly means like, this is the name of an image, load it and put it on top of the stack. And arguments that start with the dashes are commands to operate on those. And so most commands pull one or more images off of the top of the stack, do things to them, and put a result back on, or modify the one that's currently on the stack. Some of them take optional arguments. Some of them also take modifiers. Sometimes there's just a bunch of things that have defaults, but you might want to override. And so it's got a funny syntax for doing that people learn pretty quickly. Next slide, please. Great. So just a few kind of basic things that people do all day long. If you just say, here's an image, and then -O means output to the argument. Without having to specify anything else, you can do things like convert from one file format to another. If people use this to convert data types, like if you have an 8-bit integer file and you want to write it out a 16-bit or a half float or whatever, that's pretty simple. Because we have, at least optionally, OpenColorIO backing it all internally, people use this for color space conversions of files all the time. You can do a lot of things to manipulate the data in it. For example, the example I gave here is like channel shuffling. So like in this example, it's swapping the green and blue channels, and there wasn't an alpha channel, but now we're giving it one and assigning it 1 everywhere and re-outputting it. It's got a little bit of support for video files. The main application that people do for that is taking a video file and splitting it into separate frames or pulling out individual frames. Next file, please. Next slide. Yeah. Also, getting information in comparison. If you, the first example is one where it's going to print all the metadata for a file, which can be really useful. It's sort of the equivalent of something like EXR header or TIFF info, or like every individual format usually has their own thing. And this is the one that will work across all of those formats. You can get statistics, that's often very handy. And image comparison also is something that that we use all the time. Like a typical example for us is like, we have a renderer test suite where, we validate that the renderer is working by, rendering a bunch of files, and we have standards checked in, and we're basically doing comparisons of them. And, if they're all the same, we know the renderer is working. And if they differ, then we can produce different images as well. Next slide, please. So plenty of image processing operations, and just looking at the first one, you can sort of see this example of the sort of stack processing nature of it. It's naming 2 images; these are being placed on the stack. Over is a command that takes the 2 images on the top, does a compositing over, and then sticks the result back on the stack. And then -O is one that takes what's on the top of the stack and writes it out. And again, things that people use this all the time for is like resizing and reformatting, sort of conformance to the standards of like what you're supposed to deliver images to. People use it for, you can annotate it, you can draw lines and put text on and things. So people use this to, make slates, to do text burn-ins for review, all sorts of things like that. Next, please. So a few tricks that casual users might not know about, but the power users do some pretty neato stuff with this. So one thing is that in situations in studios with animation is we're very frequently not dealing with individual images, but we have images for every frame of a shot, say, and they tend to have file names that are going to have the frame numbers embedded in them. So one thing that OpenImageIO tool knows how to do automatically is it will expand frame number wildcards. So if you see something like the number sign here, like it actually understands that this means like, look for all the files that match this pattern. And, for each number that it finds across those files, execute this command with the right substitutions. And so this is the way that we do a lot of commands across every frame of a shot. Say, another thing that is that's super powerful is there's an expression evaluation syntax. So anything that appears on the command line inside braces, it is actually doing some interpretation of what's there. It can do some math. It can do a bunch of lookups. Top in capital letters is a notation meaning the image at the top of the stack. So what this middle example here is doing is it's reading an image in. Maybe you don't know what the resolution is, and it's doing a burn-in of some text, and the position it's going to be it says the Y position is height minus 40. So it's going to put it at the bottom of the frame, but scooched up just a little bit so it doesn't run off the bottom. But this is going to work no matter what the resolution of the frame is. And the text that it's going to burn in is going to be taken from the image description metadata of that image itself. So this general command is going to kind of work on any image. And the other thing that I think is a rarely known thing, it's relatively recent, is you can do control flow on the command line. So you can actually have if then else and while and for loops, and it knows what to do with that, which is kind of cool. So next slide, please. Yeah, hold it there. Yeah, so here's a complicated one, and this is fun. It's not easy to understand all on one, wrapped command line. So I've rewrapped it for you and done some indentation, and I'll give you a few seconds to stare at it. Some of you might recognize what it is, but next slide. Yeah, so that actually computes this image out of nothing on the command line. So you can do some crazy stuff with that. Not that I would advise doing it this way, but it's funny that it can actually work. It'll be interesting to see what people do with this. Next. Great. So there's also another sort of offshoot that's going on here, which is the image cache and texture system. Next. These also live on top of the basic image input and output. So these will work with any of the file formats that it understands how to read. And so this is yet another abstraction level on top of it all. And here the abstraction is, it doesn't even really keep track of which images are loaded up. The basic dialogue is like, I want this section of pixels from this named file, or I want a filter texture lookup from this position of this named file, and here are the derivatives. And it's fully virtualized, right? So there's no open and close operations. You don't have to keep track of which files are active and which aren't. There's no memory management that the app needs to do at all. It just gives the limits. It says, I don't want more than, 1,000 open files at any one time. And I want to keep it all in, 4 gigabytes of space. And the library handles everything. It tends to work best when the files you're reading are tile oriented. And if the access pattern is at least a little bit coherent. In other words, it's not going to do super well if literally every subsequent request is a different random file, and it picks one pixel that it wants, and then it's off to something else. And that can lead to a lot of thrashing. But as is typical uses, there's enough coherence that can, it's got a lot to work with. So the typical application of this is in a renderer. And just to give an idea of kind of the scalability of this, we regularly render scenes where each frame references, 20,000 or more different texture files on disk, totaling in the terabytes of total pixel image data. And this can all be done with an in-memory footprint of, I think our default is 4 gigabytes. And sometimes when we're feeling really adventurous, we go up to 8. So it keeps a fairly low memory footprint, which is really useful in a renderer where you probably need the rest of the memory to handle things like geometry. Next slide, please. And so because this all just kind of works out of the box, this library is used in a great number of renderers, commercial, in-house, and open source. So a lot of the hidden use of this library is kind of in a bunch of these products as well. Next slide, please. Wow, we're getting through this. Great. So I want to talk a little bit about what's coming in the future in terms of the release that's about to happen, as well as the roadmap. So we are at that time of year that we do our big annual release. We tend to have little releases at every month that just give you know, kind of patches and updates and fixes to whatever the current release family is, and then we switch to the new release family in the fall. We're not a VFX platform listed project, which is good, but we do stick a bit to their schedule in order to be, you know, kind of somewhat you know, timed to the release of all of those other packages. If we picked a different time of year to do our major release, a lot of the other packages just wouldn't be able to pick them up because they're not going to do their next big release until this time of year. So you know, we aim for like early September, which means we're probably going to lock down and go into beta certainly by the time SIGGRAPH is over, I think, on this. So the big improvement for this year that I want to call out is that we have a really improved integration of OpenColorIO, especially for version 2.2. So if you don't pay attention to what's going on in OpenColorIO land, 2.2 is a really exciting, this is really last year's release, but it's a really exciting new set of features. And the thing that I like the most about it is that it has built-in configs. So it used to be that, you know, at a big facility, you know, where you have a good color managed workflow and a, you know, color scientist on staff, you know that you've got the configurations that, you know, sort of have all the data you need for all the color spaces you work with easily accessible. But we don't always know where the software is going to run. And so if you're running without OpenColorIO around or without a config that has the spaces you want, you're a little bit dead in the water. And what OpenColorIO 2.2 does is there are a couple of reasonably usable configs built into the library. So if you mainly need the color spaces that are in those, you can actually get by without finding any config around at all. And we like that. So that is great. And I encourage you to read more about this. We've also beefed up a bunch of the other infrastructure around how we use OpenColorIO, including trying to deduce what the color spaces are when the names don't match our expectations. And we do that by taking some Sentinel colors around and transforming them from space to space in the things that we do find in the config and trying to make deductions about which color spaces those must be, depending on what values that we get out of it. And so that's really handy if you come across a config that has a, you know, non-standard name for something that is a space that the users are asking you for. Another thing I think is pretty interesting is I talked about the frame number wildcards. And there is a new argument for OpenImageIO tool now called parallel frames that will try to, the assumption here is if you use this, you're saying that the frames can be processed independently. And if that's so, instead of going sequentially over frames and trying to multi-thread within each individual op, like if you do an over, it will, you know, basically try to stick the threads on different pieces of the image as it works. And this is a different parallelization scheme where the command for each frame number is done with one thread, but it's trying to work on a bunch of those at once. And there are some trade-offs there, but for many cases, it's a much more efficient way of exploiting multiple threads. And there are too many other enhancements to keep track of. You'll see the release notes. There's just a lot. I do want to highlight that this is the one time of year that we can change some of the dependencies. So some of the major dependencies, we did bump up the minimum versions. So it's helpful to be aware of that. We have not bumped the GCC requirement or the C++ standard level this year, because I think a lot of us are at places where we're still using DCCs who need the old one and we can't quite give it up yet. But I suspect that this will be the last release series that before we bump to GCC 9 and C++ 17. So not this year, not 2.5, but whatever comes next summer, I think we're going to bump both of those unless people say they're still not ready for them. But I'm really hoping they are. Next, please. Great. So just to kind of briefly touch on what we think are the big items that we would like to see worked on going forward. And I can't promise that we'll do any of or all of these, certainly not all of them, but I'd love to see several of them tackled for the next major release. These are all things that we've talked about. One of them is the texture system that, as I said, many renderers are using. That's all on the CPU side. And many of these renderers are transitioning to GPU. Most of them via CUDA and optics path, including ours. And so I would like to evolve the OpenImageIO texture system to keep up with that and basically, make a, feature for feature compatible, CUDA side implementation. I think that's good for everybody. People have also asked about GPU acceleration of all of the other things we do. I think that is a great idea to explore, and I would like to find out if it can work. One of the things to be aware of there is that a lot of OpenImageIO operations, a lot of typical OpenImageIO tool command lines spend more of their time doing I/O than they do doing math. So, you know what Amdahl's law is, like the biggest, if there's a portion of what you're doing that's serialized, that puts a cap on what the biggest speed up you can get is out of parallelizing the other parts. So like we can make the math go infinitely fast, but if the actual read and write from disk is currently taking, 25% of the total runtime of an OpenImageIO tool line, making everything but the I/O infinitely fast will still only get you a 4x speed up. So like, don't expect miracles here, but let's see how far we can get. Our support of raw camera formats and movie files, especially, they could use some love. I'm not an expert in either of those things. I think that those are areas that both could use some work currently and also really need a long-term owner of each, someone who's going to stick with the project for a while and get a little bit more immersed in those particular problems and the particular underlying libraries that we use to implement those. I think that we still have work to do on improving our cross-platform building, making it easier for people to either build on their end, especially on Windows, but even more generally, including the dependencies. OpenImageIO is a library that has a lot of dependencies because we have all of these formats we need to support, and that makes for a bit of a hairy build. People have talked about, even wanting a PyPI, style, single line install. I think that would be a worthy goal. Needs someone who really wants to chase that down. Another thing that we know is going on, there is a ASWF working group on Rust for quite a while now. They have, made it clear that they want OpenImageIO to be one of the next big VFX libraries that they put a good Rust bindings onto. That's been languishing for a while. It would be nice to collaborate with them to make that happen. I think Rust is an interesting language. We'll see where it goes, but I think that we don't really have a good idea right now because we're so limited in being able to experiment with it because the major core libraries don't have Rust bindings yet. And so I really applaud their effort to try to put bindings on the ASWF and other key foundational libraries for us, because I think only when that is done can we really do the work to understand what we would get out of this language for people who want to use it. And we haven't made any decision about what next year's release is going to be called. But we'll say that when we bump the second version, like going from 2.4 to 2.5, we're allowed to break binary compatibility, but we still don't like to break source compatibility. So like we know that an application that uses OpenImageIO will need to recompile and relink, but we like to think that they don't need to edit any of their source code if they're not trying to take advantage of the new features that we add. But every once in a while, we do something like go from 2 point something to 3.0, and those are the differences where like we're actually allowed to get rid of the old things that we now think are bad decisions, even if that means that applications might have to rewrite a little bit of their source code in order to use the new way. So, you know, it's been, I think it was 2018 when we called it 2.0 and did the last source compatibility break. So several years have gone by, so it's not outrageous to think that we could have one of those soon. It's all up to us, but we just have to decide like at what point we want to take one of those breaks where we can do some, you know, cleanup and throw out the parts that we don't want to keep carrying forward just for compatibility's sake. Next slide, please. Great. So I think this might be passing it back over to Danny, but we want to talk a little bit about things to do and how to get involved with the project.
Yeah, so as we're moving to the Academy Software Foundation, this is actually a great time to get involved with the project. Because a lot of things are changing anyway, and there are a few things that even people who have been involved for a long time need to relearn a little bit. So it's a good time to welcome newcomers. I myself am a newcomer as far as like the internals of the project. I've been a user of the project and a fan for a really long time. As Larry said, we use it at Imageworks pretty much across every department. We use it at render time for evaluating textures. We use it to test software. We use it to prep materials for reviews. I mean, the uses are everywhere, are incredibly varied. And so it really is a workhorse locally. And I've worked with it for a while, so I've benefited from it. And I was also looking for a way to see, oh, how can I contribute a little bit and give back to the project? So if you're kind of asking yourself, hey, how do I dive in? How can I get involved? So there are a few ways that we are thinking about. One of them, if you're really feel that you're ready to tackle some coding issues, then Larry is going to tag certain issues in GitHub as mackerel. So the idea is that it's the name of a fish, and it's a kind of a good issue to learn how to fish. So it's got some meat on its bones, meaning that you're going to be required to do some digging, but it doesn't require you to go too deep into the belly of the beast. So it's kind of a good in-between issue for you to sink your teeth into and get into the internals of the system. If you want something a little shallower, then there's an upcoming dev day that the ASWF is organizing. And that is kind of like a hackathon that is going to be using different components that are part of the ASWF software packages that are under that umbrella. So OpenImageIO is one of them. So that is going to be a fun activity. And one of the tasks that we thought about that would be a good dev day task would be to go over the docs that we provide. And over there was a lot of code snippets, and some of them could be a little bit out of date. So it's a good opportunity to run the software, test the code snippet. And if the code snippet needs some updating, you can update it and turn it into a unit test. And this way it'll carry on functioning. And so we'd be updating the doc, but that alone, you know, gives you the opportunity to check out the project, build it, get to the point where you can run the API and start making some pictures with it, which is cool. We're open to additional TSC. So TSC is the Technical Steering Committee. So we have representatives from a lot of the big VFX houses and a lot of stakeholders. And there are still open seats for anyone who is interested in joining. And here we have a few links. So yeah, I think a great place to start is the Slack channel. So that is a place that we're all watching, and we can guide you from there on how to get involved. You have the GitHub repo has a lot of good, a lot of the heavier discussions happen there in issues and like pull requests, the mailing list. And we also have a bi-weekly meeting of the technical steering committee. So you're welcome to join in, and a lot of the discussions, you know, the in-person discussion will happen there. But yeah, if you're looking for a good place to start, I would start with a Slack channel. That is a kind of a great place to start asking questions. And
hey, Danny, can I get, I want to give a little bit of an extra plug, an explanation of the Dev Day. So that in particular is for trying to draw new people into the any of these projects and give people who maybe haven't done any open source contribution to these projects, or maybe to any before, a chance to find something that can be done basically in a day, and give them the chance to dip their toes into the pool. And because we'll all be doing it on the same day or two, you know, the major contributors of these packages will kind of be on hand to give them some guidance and help, and be there to review things. And the companies may find it easier also to, sometimes there's some bureaucracy involved in getting people permission to work on a project, and maybe by a bunch of people trying it at the same time, that at least can be done as a batch, and doesn't, you know, every person doesn't have to figure out how to navigate it by themselves. But you don't need to be at an ASWF member company to participate. It's open to everyone. You know, it's fine for students, it's fine for people at other companies, but it is also good if you're at one of the big member companies. You know, I think a lot of them are in a situation where, even if the company thinks of itself as a major open source contributor, or maybe the origin of one or more of these packages to begin with, very often there's still only one or two people who do kind of most of the deep dives into them, and they could use some backup. And other having, you know, it's just risky at any place to have in your organization like only one person or two people who are comfortable going in and enhancing or fixing one of these foundational projects that the whole organization is really quite dependent on. So this should be thought of as an excuse of how to spread some of that knowledge around, and maybe find some junior developers on your team who you think it would benefit them career-wise to have this experience and to be more involved with these projects and their peers across the industry, and try to rope them into it. So that's my pitch for it. And I've agreed to co-chair this, but really Carol, who's also on this call, is the leader of this effort. Watch for more announcements about this. We would really like to turn it into something that gets a lot of participation. And one of the reasons that I think this project is really good for it is, you know, frankly, there are some ASWF projects that are so esoteric and specialized in the knowledge you need to approach them and think about things to change, that it can be pretty daunting if you're not already kind of narrowly focused on that area. But I think OpenImageIO is kind of neat in the sense that I think a lot of people understand what an image file is conceptually and have some use for them in their lives. And so there's a little bit more of a personal connection to something that this project does. You know, if you're not working with volume, you know, files, like it's hard to know what to do on OpenVDB. Not knocking them in any way. It's an incredibly important project, but I think ours is an approachable one. So I would like us to be extra welcoming to get new people involved in the project and in open source in general. I just think it's got that nice approachable quality. There are deep parts of it. There are certainly big sections where like no one's going to know what to do if they're not quite deep into it, but there's a lot of open field areas where I think even new people to the project can find things to work on that are already things that they would care about and would be understandable. Did you I know Carol's on the call. Carol Payne, do you have anything you want to add about that?
I don't think so. I think you covered all the details, Larry, and like you said, just look out for more announcements in the future shortly, I think, because details are going to have to come soon. It's coming up quick.
Did we say something about having to sign the CLA in order to participate?
Oh, no, but thanks for the reminder. Yeah, right. Like, so the reason that this is scheduled for October and not, tomorrow or something is like, we know the people and the companies need a little bit of lead time to prepare. So like, if you're one of the leaders in this company that's already involved with open source, like, okay, you got a couple of months to try to like find a couple of those juniors that you think should be involved and haven't been yet, and kind of recruit them into the process. And if it's not a project that you've contributed to and signed the CLAs for, this gives you some lead time to, get your legal team or whatever else is necessary to give that okay to contribute to the particular projects that you're thinking about, and do the paperwork like getting the CLAs signed or whatever it is that you might need to do. So don't wait till the last minute. If you're in an organization with a lot of bureaucracy, use that time wisely. We hope we gave enough lead time that people can actually hit the ground in that October timeframe and actually be ready to let people take on these small projects and not get bogged down in finding themselves in the middle of that day and not knowing what they have permission to do, or this, CLA isn't signed yet or whatever. Let's get that stuff out of the way now. So if you're in one of these companies in the position to make those things happen, that's your signal.
I think we have a few minutes for Q&A still.
Yeah, that was all of our formal presentation. So
yeah.
Well, Larry, you have a question from Robin in the Zoom chat.
Yes.
I don't know if you can see it, or I can read it for you if you want.
Why don't you read it?
Not so much a
people
question
seeing
as
the
just a
video later.
suggestion that I'm impressed by the / command line programming, but in reality, when we do stuff that's that intense, we prefer to put it in a file.
Yeah, no, that's a good idea. I mean, to be okay, first of all, no one should be computing fractals with OpenImageIO. And probably if you were going to do something like that is really the time that you switch to writing a Python script and not doing it all on a command line. But I mean, it's mainly sort of a game to illustrate that you can be pretty flexible. But yeah, it's interesting. So right now there is not a way to sort of get the command line arguments from a file, but that's kind of a neat idea. Also, we have
or even in a Unix standard, redirect. Just be able to do the less than sign and, or pipe it, whatever.
I think that will be a great feature for someone to add. And I think it's yet another one that you like, really, that's just some general programming, and you don't need to know any of the deep guts of the OpenImageIO in order to do that. And people would find the results very useful. And a related thing that we've thought about before, but never did is, right, so we have Python bindings on the APIs, but we don't have a Python interpreter inside OpenImageIO tool. And I think there could be some utility to that. For example, allowing people to extend the command set itself easily with Python scripts. Yeah, I think there's a lot of opportunity there. Again, needs people. As Danny alluded to before, I think one of the nice opportunities that turning the project over to the ASWF affords us is kind of lowering all the barriers. Like, there is no in-group, right? Like, the TSC just formed. There aren't these like entrenched, people, other than me, who's been at it for so long that like, there's open positions, right? Like, you can literally move yourself into a major position of influence pretty much by stepping forward and doing the work. There's not an in-group yet. So it's a really good opportunity for new people to get involved. we will be having an in-person BOF at SIGGRAPH. It's on the schedule somewhere. And I don't think we're going to recapitulate like a formal presentation like this there. It is, I think that one will be one where it's more about meeting people in person and letting a more informal discussion happen organically, including trying to talk about like some of these items that we're thinking about in the future. You know, which ones do we really want to tackle, and who's going to step forward to do some of that work, and set priorities and so on. So that, I think that's the kind of thing that we can do at that next meeting as well.
Yeah, I believe it's Monday at 1 p.m., but we can post on the Slack channel. We can post the actual time.
Thanks. Great. Thanks, everybody. We'll see some of you at SIGGRAPH.
See ya.
See you there.
Yeah, hope to see you in person next week, whoever comes. So.
Yeah, thanks a lot.
Thanks.